Thanks very
much.
Well, welcome everybody. And
yeah, thanks for coming. Obviously, there's other events on later that might be a distraction. Yeah, so I guess one of the reasons we were invited to talk this week was our involvement with the Science Gallery through the exhibition that's on at the moment. So I don't know if you've seen it, but we have a kind of visualization outside, which is basically looking at how water flows through Dublin in terms of the DMAs, and also we're looking at domestic water usage, some kind of snapshots on that. So I guess you're probably wondering why would IBM be interested in water? Well, IBM has this big thing which is called a Smarter Planet. So it's basically this assumption, and it's kind of true as well, that the world is becoming more and more instrumented. So there's sensors everywhere. Obviously, anything from your iPhone with kind of motion sensors. And then the idea is that you have this instrumentation, but you need to connect it, and then ideally you need to understand it. So you want to kind of add intelligence to it, and that's what the research lab in Dublin. That's its kind of main aim. There's a section in analytics and optimization, and it's hired a lot of people, and it's actually still hiring. So I don't know if you want to talk about some of the flows stuff, and I can jump back in.
I think this is supposed to be a popular science meeting, so I start from the bottom. Right. So people have been dealing with water for many years, and then really it was probably in the 80s that started what is called the sort of analytics revolution. Now, for the layman, what analytics means, it means that you start to take a lot of mathematical, statistical, engineering concepts, and you start to plug them in for stuff that happens every day. It can be seen in a very science fiction fashion, in a very scientific one, in a very technical one. The truth is that it's happening more and more. Like, for example, analytics now are used on everyday scale. You log into Amazon, then it tells you what's the next book that you're going to buy. You have your Tesco Club card, and you get your points, and they are basically going to monitor you and tell you what's your preferences, etc. So IBM, something like in the 80s, after this whole introduction of mathematical techniques and statistical techniques, started to think how to bring analytics into, say, planet experiences. And they started this huge program that was called Smarter Planet. And the idea was to start to adopt more intelligent systems into domains like water, electricity, transportation, etc. So water, as we perceive it, has always been a very conservative environment from this point of view. It's really starting to change in the last few years. And the reason why it's changing it and it's starting to pull up all these kind of needs for analytics is because people are starting to realize that it's a very scarce commodity. We are ourselves here in Dublin, after I think decades of having access to free water. Probably we are going to have flat rates and water meters very soon. And from this on, the access and the need for much more clean water and for much more controlled water is asking governments, institutions, etc., to have a much better monitoring and much better control on these kind of resources. Like this is a bit what we tried to do with the installation over there as well. We tried, that was very basic, again, very much on a popular science context, that was trying to show just how water is used in Dublin. I don't know if any of you have seen it. It's down there by the corner. it shows how water is consumed in Dublin. Basically, you have this map of the city, and that is divided in districts. So we got data from Dublin City Council, each district, and we are mapping the consumption, showing this kind of moving mountains and the patterns in the whole environment. And this was just to show how data and analytics can start to build up a conscience of how water is consumed. This just in Dublin. Another basic example of what we are trying to do, for example, is floods. So you have all these environmental approaches to floodings, and what we need to do now is using all of system of sensors that we have access to, radars, met stations, flood meters, etc., to be able to predict in real time what happens when a flood hits a city. From the most extreme events like tsunami, for example, in Japan, to something that still affects a city, like in Dublin a couple of weeks ago. So what we can demonstrate and show, and what already exists, for example, are systems out there that are able to predict you road by road what happens when a flood hits a city. And you can actually see not only how a column of water, how the water depth is hitting the topography of a coastal city, but you can actually see how fast is the impact of water on the civilian structures, on people, on cars, etc., etc. I think.
Yeah, just something else that struck me. The other thing with IBM, I know we're talking about data. A few years ago, we did a project with the Marine Institute that involved Clarity. So that was UCD and DCU, and the project was called Smart Bay. That was more on environmental monitoring of Galway Bay, but part of that did have a water quality aspect where DCU developed a phosphate sensor. So again, I don't know if you see one of the exhibits outside, it shows kind of a standard kind of a lab bench measurement for checking nitrate. So it's, you know, something that's equivalent to kind of litmus paper. You know, you're looking at a color change. So what DCU did, and as part of Clarity, was they basically developed a device, essentially like a lab on a chip, so that a colorimetric sensor for phosphate. So one of the projects that IBM were also involved in was basically trying to add some, in inverted commas, intelligence onto the device to basically change sampling rates, you know, based on the detection of an event, if it looked like, because with these types of reactions, it actually takes, you know, a while for the water to mix with the reagent. So it's not something that you can just kind of flick a switch and say, okay, tell me what's happening. You know, there's a certain period of time, so if something does happen, you might want to go, okay, there's an event here, let's actually start sampling a lot more than we would. And so I guess we're also interested in sensing as well, and kind of pushing intelligence further down onto devices. So maybe you know, action in terms of sampling can change more local to you know, to the actual event.
Yeah, and from this exactly, picking up the example of a Smart Bay. Smart Bay is basically this whole set of buoys and sensors that are out there in the public domain. Everybody can go and go into their website and check their data, etc. And but one of the most very important thing of Smart Bay, for example, is that using all the data and all the sensors that are out there for Galway, that is becoming one, actually, from this point of view, of one of the most important geographical locations in the planet. It started to be considered one of the big pilot projects for the application of analytics to marine environments, is that as well with the set of models and with the set of artificial intelligence structures that we can build on this kind of sensors, we are actually able to model almost perfectly how the water is flowing in the bay. And that means, for example, that at a certain time, at a certain moment in time, if somebody, for example, falls from a boat, the system that is built on Smart Bay is actually able to tell the Coast Guard where they should go in order to rescue that person. So we are actually reaching this kind of system without even talking about if there is an oil spill or this kind of stuff. So you are actually able to understand and to predict where the oil is going to flow. A very recent chat that I had with the atmospheric physics department of the University of Galway is that all these techniques that have been developed not only by IBM but by the University of Galway, by several institutions around the planet, we are actually, the scientific community is actually starting to think how to apply them for volcanic ash, for example, such that there is this very interesting system of laser radar that they work in a way such that you put this device on the ground, it shoots a laser up the sky, and it's able to measure the density of the clouds. If you start to couple that with the atmospheric physics models, you are actually able to predict and to understand and monitor the density of volcanic ashes in a cloud, given the fact that another volcano might erupt. And several airspace authorities around Europe are very interested at the moment in this kind of research in order to avoid all the disruptions that happened last time. I think so. I don't have much more to add.
Yeah, well, just as well. I think in terms of science and open science, like sites like Galway Bay and let's say marine science, you tend to find that people share data a lot more. There's data publicly available. Like if you're interested in remote sensing satellite, you can basically write an abstract for the European Space Agency and they'll give you access to data. So it's definitely, it's a very interesting area in that it's not like, let's say, if you're working with a council, there's commercial sensitivities to some of the data. It's not something that you can make, necessarily public. You can make maybe summaries of it public, but you can't really hand over the raw data. Whereas if you're working with the kind of satellite stuff or, data from buoys, it's quite interesting because it opens up, more room for collaboration. You're not working on something that somebody will kind of go, well, there's something very sensitive in this. We can't, share it. So I guess in terms of the, science being more open and feeding back into Smart Bay wouldn't have happened if there hadn't been all these kind of data sources kind of freely available that people could use.
Yeah. So, yeah, right. I think we can more or less conclude. I mean, so if we would have to share our experience up to now in this domain, is that it's becoming a really very interesting domain in which you start to couple new sensor technologies with modeling or artificial intelligence techniques in a way that probably 20 years ago was not really foreseen or was foreseen only by a few visionaries in terms of where it could go. And it's becoming extremely exciting, and it's progressing really fast.
questions for either of the guys? There's loads.
I was interested in you mentioned there the idea of pushing the intelligence down into the remote sensing devices. Interesting idea. I wondered what you meant by it specifically.
Yeah, well, in this one example, it was basically the intelligence in inverted commas was really about changing sampling rates, being able to detect an event has occurred.
Yeah.
But there was also another layer to that in that what we'd done is we kind of looked at it that, okay, the actual, let's say, embedded software on the device, we did it that it could be flashed, that you could completely update it. You know, you just dial in and do it rather than having to go there and, you know, swap the hardware, and also that you could do it if you had thousands of devices within a few kind of milliseconds. But I guess, you know, you could say, well, how intelligent is that? So I guess maybe it's intelligent in that you're trying to adapt to what's going on in the environment, but it's still, you know, it's still relatively simplistic, but you're getting more than you normally would, kind of thing. You're trying to react to what's going on locally, maybe before it gets pushed further up for some other system to make a decision on.
Would the conventional system be where somebody goes out and takes a sample physically?
Yeah, it can be, like for phosphate, I guess. I mean, that would happen a lot. And then the thing with that is, well, is that you say what tends to happen with sampling. People tend to sample whatever is closest to the car. So, you know, you're supposed to maybe sample, like, I don't know if it's a river in the middle of the river, and you're supposed to, you know, go through a certain procedure, but do you know if people really do that kind of thing? And then the other thing is, because it's kind of a snapshot, you might be doing it once a month, at least with these devices, even though it might actually only be sampling every half an hour or every hour, you know, initially at least you're getting a much better, you know, idea of what's going on, because, you know, you do hear stories about people being kind of selective when they sample or where they sample, you know, if you want to look good kind of thing, and you know there's maybe some outlet that's, you know, pumping something in, maybe you go further upstream, or if, you know, it pumps out at 12 o'clock at midnight, maybe you wait, you know, a certain period of time before you go back and sample. So, but then the other thing with this kind of thing is that sometimes the more you look, the more problems you find, you know. So sometimes, like, I guess it hasn't always happened, but sometimes you could have a very good sensor, but maybe people don't really want to use it because basically you're finding more problems for them, and maybe they have enough already. So there is a kind of, there's a real world aspect to it as well. Yeah.
Is there a funding or commercialization pathway for this, or is this a pure research pursuit by?
Yeah.
Well, there are both aspects. Yes, there is funding and commercialization, and true, you get companies like IBM or DHI or others that are actually making money out of this. But at the same time, it's a big public scientific area. So, like, for example, as I said, Smart Bay was built by a consortium of both universities and industrial partners, but it's out there available to through the Marine Institute, available to everybody.
And some of the research projects, they would, if there was university partners, there might be like funded PhDs, you know, the kind of industry supported ERC as well. But I mean, at the end of the day, it's still, a company that.
Water is considered one of the new frontiers for businesses from this point of view, where the big money is supposed to be. So there is, for example, a big interest at the moment from oil companies, for a planning perspective, for building offshore, or even for wave energy and tidal energy companies. Again, for planning purposes, in building real-time modeling systems to understand how they affect the marine environment. And it's not they are doing that because idealistically they are particularly ecologically sensible, but it's because from the European Commission, it's kicking in a very big water directive about water quality that is restricting very much the standards for water qualities in both oceans, rivers, and drinking water.
Yeah, there's even an interesting one now on kind of noise. You know, if you have this equipment in, is it making noise that's going to interfere with, you know, mammals or whatever, you know, that are passing through? So there's a big thing on that as well. And I think the standards for that still sort of have to be set. Like, people know it has an impact, but they're not sure what they should measure against. So that's something else that IBM have got involved in as well.
Any more questions?
Just wondering, is any, like you mentioned about consumption and potential for water taxes, you know, how is this feeding back in? Is anyone using data like this to inform policy? Or?
No, but the usage of data within this domain, for example, that can help you to predict leaks, for example. And now I don't have the statistics with me, probably Jer can help me much better. Water lost through leaks, it's a big factor in an urban environment. And
well, I guess like like the housing data there, I mean, what you can spot the people who are leaking, you know, almost straight away without anything too sophisticated. And apparently that has happened where but basically you're saying to the person, the leak is in your garden or it's on your side, you know, so that's kind of letting people know, actually, you have a problem here. But I guess so that's kind of outside the network, but then you can also use it internally within the network. But I guess one of the funny things with the cost of water is, you know, we're going to be paying a flat rate, but even when we pay for consumption, we're still not paying the full cost of the water, and the cost is actually transport to our houses, and then there's a smaller cost for cleaning it, but the biggest cost is actually getting water to people, you know. And if you look around on it, even when people are being charged for it, they're not actually being charged the actual, you know, the full cost for it. So it's kind of interesting that way.
Just a comment, I was reading just in terms of water charges, I was reading recently that Ireland is going to be probably the only, if not one of the few countries in the world that doesn't have consistent water charges to the individual householders. And obviously that is something that's going to change over the future. I was wondering, in terms of your own personal opinions on that, like just when you look at different countries across the world, it's like obviously charges with property taxes and things like that as opposed to, you know, standard household things. What's your personal view on that? You know, as a nation as such, from your experiences, really thinking about that on a global scale.
well, for example, I think it's obvious that I'm not Irish, so I actually grew up in Italy and I spent part of my life in Germany and in Spain as well. And they are all countries with water charges, and not flat rates. They are water charges that are proportional to how much you consume. So when I moved here, it was actually quite a strange experience to have access to free water. And one of the justifications that I was given was, well, it rains so much. Why can you charge for something where it rains so much? And but then when you look into details, it's true, it rains a lot, but you still need to clean it, you still need to treat the waste, you still need to transport it around. It is, although I understand, so probably a sociological rather than an ethical question to understand, should you pay for something when you pay already taxes on other stuff, etc. That's that goes beyond my domain. I mean, I'm a scientist or a technologist. I'm not a policymaker. Of course, it's going to affect my wallet like everybody else from probably next January. So.
I just wanted to ask what IBM's interest in this particular project is, or is that sensitive?
The
Is it to develop instrumentation, or is there a corporate social responsibility, or what way is it?
It's not really in the instrumentation. It's more in the kind of analytics. You know, it's the whole thing of, well, you know, maybe there's, I guess the idea is that the kind of cities of the future, like say in China where there's more development, it's getting closer to the coast, which is much further away maybe from the water source. I guess it's posed to lots of different things, like optimization. If you're managing the network, what's the best way to manage it? If there's a problem in the network, like leak detection, you know, can you take your information on the network and basically, you know, you've got huge amounts of data, can you process it quickly to identify where there are problems? So I guess it's going more towards helping the people who run the cities. I mean, there is the whole thing that, you know, there is obviously the benefits if you can improve the water system and that kind of thing. It helps everybody, but I mean, that's my impression anyway. That's where it's being pitched at.
Could you give us a sense of what the research centre is like? What's the scale of it? What kind of projects are going on?
So generally speaking, the research center is not only about water. It's about 4 main areas: transportation, energy, water, and buildings. And all of those areas involve the introduction of artificial intelligence systems within those domains. We are at the moment, I think, something like 30, 40 scientists. We will grow up to 200, and that's more or less it. And
yeah, there is supposed to be, and there is a kind of a, it's not just research lab, it's supposed to be research and development, because in Dublin there's a large software group, or software lab, so the idea is that there should be more collaboration between the software and the research, so if there is something interesting or a new idea, that it can kind of be pushed further, you know, I guess developed to a high standard and given out to people. But I mean, having said that, I mean, there's still advertising for people, you know, essentially postdocs is what they're looking for, mostly in kind of analytics, but sometimes subject matter experts, like if it was water, energy, or transport.
Do you have collaborations with university researchers?
Pretty much, yeah. I collaborate with the University of Galway. We have a few collaborations with Trinity, UCD, Cork. So most of the Irish universities are more or less mapped.
Yeah, with the DCU, it'd be with the computer science and some of the chemistry people.
With the study that you made of the water in Dublin, in terms of as a resource as opposed to threat from flooding, what are the main areas that you identified as, I suppose, like the most critical areas?
As prone to flooding.
Yeah.
So there are two aspects to be considered. There are two main types of floodings in Dublin. You have the coastal one, like that happens, for example, Clontarf. I think it was 2002, the floods such that even the buses they couldn't get through. So that's a combination of rainfall, of the tidal movement on the bay, etc. Then the one that happened a couple of weeks ago, that's much more a pluvial event. And for that it's not necessarily coastal areas like Clontarf, but more internal areas. Some part of southwest Dublin are very prone for that. So yes, and we actually did not identify those areas. For this we collaborate with the Dublin City Council, and they have already a map with where they map the different level of risk for the different areas in Dublin.
Any more questions?
I'd like to ask one more question.
Yes.
Yeah, just sorry, okay, listen, your activities are in the Republic of Ireland, or the Isle of Ireland. Are you in collegial sort of fraternal work around the world, like other parts of Europe, the United States, and so forth?
Yeah, well, as a matter of fact, yes. So, as a research center, Dublin itself, we have few activities. Like we are involved on a project with Singapore, and some other stuff in Washington in the States. Then, if you're talking about IBM Global, then there is much more stuff. Like at the moment, there is an operational and live model for what happens in Rio, for example, if a floods hit Rio, and the same applies for Brunei. There is another one in that was deployed in New York before Irene hit the coast there, and that was actually managing to map road by road how the rain and the wind were affecting the city itself. And so there is few stuff. If you talk only about water, then if you talk as well about transportation or energy, there is other stuff. Like there is, for example, for transportation, there is a live model of overall the public infrastructures, buses, etc. for Stockholm that is used by the city authorities already.
One last question, anybody?
Are there any similarities between wind power generation
I couldn't hear it properly, sorry.
Are there any similarities between wind power and water sampling, what was spoken about tonight?
You are asking about the tidal energy.
Wind power.
Yes.
Wind turbine.
Mm-hmm.
Any similarities?
With regarding to similarities to
What was spoken about tonight? The infrastructure.
well, as a matter of fact, yes. So when you started to talk about wind power, you start really to talk about the smart grid. So before the renewable kicked in, there was this idea just to have a normal grid that absorbs energy, and it goes through these peak cycles of loads, etc. Now, because you are dealing many times with the wind farms, and many times the wind is not that unstable, but it's a fluctuating source. So there is very much the idea to build systems that can predict not only the distribution of wind, such that you can understand when you have the maximum production of energy, but also to balance the loads on the grid of the electricity in terms both of usage and in terms of production. So there is a lot of work going on in that area.
Guys, I'd like to thank you both for talk. Give them a round of applause.